Sorry about that. I don't know why the video just stopped. So, which is 11.772. So we got one speed as 11.772. So I'm just going to write it here. 11.772, and then we can use s is equals to ut plus half ad square, or just v square equals u square plus 2as. Final is 0. We have 11.772 squared. It's just, I'm taking all the significant figures because as I want as less error in my answer as possible. That is why all of that. Okay, and this is 19.62. S is so this is coming around 7 meters. So calculating this, so S is coming around 7 meters. So it goes up 7 and comes back 7. So the answer is 14 meters. You know, when you're solving the multiple choice question for the first time, it would think that's just 1 mark question, should be done like quickly. But remember, we're still learning. That because we're still learning, we are doing all these steps. Once we get the hang of it, it will not be as difficult. Of course, then 1 mark question is going to take 1 minute once you're at the end of year 13, and then you are just revising and then writing your final exam. Okay, let's just do the next one. Sorry. Small water drops leave tap with 0 velocity. So there are small water drops which are leaving the tap with 0 velocity at interval of 0.2 seconds. So the first drop is leaving, and then the second drop comes after t equals to 0.2 seconds. They then fall freely for 0.8 meters to reach a horizontal surface. So the tap is at a height of 0.8 meters. How far has a drop fallen when the previous drop hits the surface? So whenever any drop is hitting the surface, where is the drop, the previous drop? Okay, so what we're going to see is how much time does it take to travel 0.8 meters. So I'm going to just use S is equals to ut plus half ad square. So S is 0.8, U is 0, A is 9.81 times t square. And I'm going to just use my calculator to get this. So this is giving me around t equals to 0.4 seconds. So it takes 0.4 seconds to come. So I think 1 drop is starting, 1 drop is somewhere here, and 1 drop is hitting the ground. So this has taken 0.4 seconds to hit the ground, and this one has traveled for 0.2 seconds. How far? So they want this distance, how far this drop has fallen. So we're just going to use the same equation, ut plus half ad square, and then I'm just going to clear this. So what we're doing is we are going to calculate distance for the middle drop. It has fallen for 0.2 seconds. So I'm just going to use initial speed is 0 half 9.81 times 0.2 squared, which is just calculator, which is coming around 0.19 something. So my answer is 0.2. Which graph best represents the velocity time graph for a ball that is dropped from rest and bounces repeatedly? Okay, so first few points for the velocity time graph. A ball that is bouncing, what kind of acceleration is acting on it? One acceleration is acceleration due to gravity. Okay, second when the velocity is coming down, it has one direction, and then it bounces off and the direction changes. That means your velocity time graph should have two directions of velocities. So this does not happen because this has only positive, positive, positive velocity. So it does not happen. This cannot happen because the gradient is constant, and obviously, okay, forget about the gradient. This is also again positive. So this is also not the right graph. Again, only positive side, not the right graph. Positive, negative, positive, negative, positive. Okay, so this is the right answer. Now let's understand why the lines are parallel. Okay, what do these lines shows? The parallel lines, these why these lines are parallel? What is the gradient of a VT graph gives us? The gradient of a VT graph gives acceleration, and because it is acted upon only by one acceleration, that is gravity, which is same, so they all have same gradient because they have, it is always under only one acceleration, that is acceleration due to gravity. Now the answer is B. A firework is fired vertically up into the air and subsequently falls to the ground. So it's fired up, goes up, 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 and falls into the ground. Fine. Which quantity relating to the motion of the rocket is never zero before it hits the ground? So just before it hits the ground, which is never zero. Is velocity never zero? What about when it's at the highest point? When the rocket is at the highest point, or the firework is at the highest point, is the velocity zero? Yes, of course, the velocity is zero at the highest point. So, yes, the velocity can be zero. What about its acceleration? Okay, forget about acceleration for now. What about momentum? The velocity is zero at the highest point, so obviously the momentum is also zero at the highest point. So, kinetic energy is also zero at the highest point, but it is always under the acceleration due to gravity. So this is right. Okay, so that's about it. That's such simple one-dimensional motion. The next video for AQA I'll be making on projectile motion. So done I'm done teaching projectile motion. So just do one thing, go through the video of projectile motion. I've put some basic questions there in the concept video. Go through them, and then the next video I'll be making, I think I'll be making tomorrow, I'll be making that video for projectile motion specifically for AQA. Till then, keep practicing, keep learning. Bye bye.